Hello, here's another video from sickmaths.co.uk where you can find so many maths videos. This one's about F equals ma, the formula F equals ma, force is equal to mass times acceleration in equilibrium. That's like when things are not moving, so all the forces are basically balanced. So let's talk about a typical question. There's a mass of 2 kilograms over here, that thing there, on a 60-degree slope. So there's your 60-degree slope, and it's on the verge of rolling down. So it's about to roll down, but not quite. And what they want to know is find the coefficient of friction, mu. That looks like a U, but a kind of extended thing coming out the side, and that's a typical letter to use for the coefficient of friction. And also there's a 10 Newton force acting on a particle horizontally. There you go, there's your 10 Newton force. Okay, so N stands for Newton, and all forces are just measured in Newton. So for example, I've got this force 2G, the weight of the particle. I don't write newtons there, but it automatically means newtons. We measure in newtons. So let's do the working out. What you do is you measure forces, well, you can get equations at least by looking at forces perpendicular to the slope, yeah, right angle to the slope, and along the slope. So to get your second equation, you can go along the slope and perpendicular to the slope, you can get another equation. So let's go perpendicular to the slope. F equals, using F equals ma, you say R, let's say that direction positive, going in the R direction, yeah? So R minus 2G cos 60 minus 10 sine 60 equals 0. Okay, so because mass times acceleration, since there's no movement, there's no acceleration, so mass times acceleration, whatever the mass is going to be equal to 0. Anyway, but how do I know it's cos 60 and sine 60, and where the heck did that all come from? Yeah, so there's some important things to get used to here. Once you've seen it, you can just take it for granted, and here is that thing you should learn and take for granted eventually. What you do is, I've got my 60 degrees here, and I redraw this whole triangle here, and this is the point where the particle is over here. Okay, and if I draw a line that is perpendicular to the slope here, basically this thing is 90 degrees. So there's an angle here which is obviously 30 degrees in the corner, and then this other angle has to be 60 to add up to 90. And this always happens. Whatever angle that happens to be, that angle is also going to be the same angle. Okay. Now, if you look at this line going downwards, which is your hypotenuse, it represents this force 2G. I've purposely drawn it all the way down so I can make a nice right angle triangle, but the point is, the force over here, as I would have mentioned in an earlier topic called vectors and mechanics, is representing the hypotenuse. So you just make a right angle triangle and you can work out the components of this force in this direction and that direction. Okay, so how do I work out, say, x, which is the component that is going exactly perpendicular to the slope? So I do 2G, there you go, that's 60 degrees, so cos 60 is equal to x over 2G, because x would be your adjacent and 2G would be your hypotenuse. So that's that. So cos 60 equals x over 2G. Rearrange it to make x a subject, get x equals 2G cos 60. So 2G cos 60 is the amount of the force of this weight force that is going down, that is acting in this direction. Okay, because if you think about it, some of it's acting in that direction and some of it is making it roll down as well, which is what we're going to work out in a second, which is the y bit of this triangle, which is basically parallel, or well, along the slope, yeah, the direction of the slope. So parallel, or you can just say along the direction of the slope, whatever. So let's work out y. Well, to work it out, you say y over 2G is equal to sine 60. bit of simple trigonometry. Rearranging gives you y equals 2g sine 60. Now, what is the bit that you're supposed to memorize and get used to? Well, if you're perpendicular to a slope, it's always basically the weight cos the angle, and along the slope or parallel to the slope is the weight sine the angle. So sine 60, the weight sine 60, the weight cos 60 for perpendicular slope. So once you know that, you just take it for granted, okay, and it really speeds things up. So, and you can just write it down. They don't expect you to draw this triangle and do all this working out again and again. So let's get back to this. So R, we're going back to the perpendicular direction to the slope, yep, so R minus 2g cos 60, because perpendicular means cos, yeah, that's 2g cos 60, and there's a weight which is, there's this 10 Newton force. Now, you know this 10 Newton force, it's going horizontal, what did it say? Horizontally, right? So horizontally means, well, there's a floor here which is also horizontal, we assume. So this line, horizontal line, is perpendicular to this horizontal line, which means if you have an basically this angle is alternate to that angle using parallel lines, yeah? So that's automatically 60 degrees. And then what happens? Oh yeah, so I have to work out how much of this force is going perpendicular this direction. Now, it's not the same as this particle, which you automatically assume is cos, yeah? Because it's always going to be in that situation that there's going to be a particle on the slope, and the way you work it out is the same way as always, yeah? It's going to be cos. But this one is not about... This force is coming from a different direction, different place, whatever, so you have to think of it differently to this particle. And so you've got your angle here, and I want to look at the force going in this direction. So imagine a little triangle going on here, okay, where my 10 newtons is again my hypotenuse. There's my angle, 60 degrees, and you can see it's going to be sine to work out this the opposite side of our triangle that I'm kind of marking out with my little pointer. So anyway, so basically I'm saying that the component of the 10 Newton force going perpendicular to the slope is 10 sine 60, as I've written there, and it's minus because it's going the opposite direction of the reaction force R. Yeah. Yeah, I didn't talk about the reaction force. Reaction force means because it's not moving, and forces must be balanced always. If they're not balanced, that means that our overall thing is moving. Yeah, and it's obviously not moving in this perpendicular direction. That means the reaction force must be equal to the force going down. So there must be a force going back up, which is keeping your balance. That's the idea of reaction force, to react. Anyway, so that's loads of explanation as usual. So you got your reaction force minus 2g cos theta minus 10 sine 60. I said theta there, I meant 60 there. Anyway, equals 0, because whatever. And then rearranging gets you R equals all this stuff, just bringing it over to the other side. Okay, so that's one equation. Then I've got F equals ma parallel to the slope. Okay, hopefully this will be quicker because I've explained all this stuff, this really basic stuff already. So parallel, as we said, that's the y bit, which automatically means sine 60. Yeah, the weight force going parallel to the slope is 2g sine 60. So we're taking downwards as positive, as it looks like from here, 2g sine 60, and then all the forces going the other direction are the friction force, because it's about to slope down. What is it? About to, on the verge of rolling down, it says, yeah? That means the frictional force has to be going opposite direction to the direction it will be moving or about to move, okay? If it was on the verge of rolling up, then the frictional force would be acting the other direction automatically. It's just the way it is. So, well, it's not just the way it is, I explained why it is anyway. So, So, as I was saying, the force downwards, 2g sine 60 from the weight is that way, and then you've got minus 10 cos 60. That's, again, make your little right angle triangle for this 10 newtons, where 10 newtons is the hypotenuse, and this time we want to work out the adjacent bit, which means you're going to do cos, yeah? So it's going to be 10 cos 60, because this is 60 is our angle that we're working with. Okay, minus FR. FR stands for the friction. And what is friction? The formula for friction is the coefficient of friction times the reaction force. Okay, which totally makes sense, because the coefficient of friction tells you how rough the surface is. Okay, coefficient of friction is the coefficient of friction for a surface, and it depends also on how much pressure is being put on the surface. So, for example, you might have a really heavy object, but if you're kind of lifting it so it's hardly touching the floor, there's not going to be much friction on the floor. Okay, but if you're putting a light object even, and you're pressing it down, okay, and then rubbing it across, across the surface, that surface is going to create more friction. Yeah, so that's the idea. So there's a coefficient of friction which tells you how rough the surface is, and also how much pressure you're putting on the surface, which is the reaction force, and time them together give you the overall friction. So that's that explained. Okay, so that frictional force is replaced with that. Okay, and then all you have to do is, there's only one thing you don't know, which is the coefficient of friction there, and everything else is known. G, if you didn't know, is the acceleration due to gravity. Okay, 9.8 meters per second squared. You should know that. Okay. What else is there to say? Yeah, that's how you describe the weight of something. Yeah, the weight is a force, and the force is worked out as mass times acceleration. The mass is 2, and the speed due to acceleration due to gravity is g. Okay, so which is 9.8. So yeah, we stick it and rearrange it and make mu the subject, and you get mu is 0.65, and that is the end of the video. Phew.